Welcome to massive open online course on chemical process intensification. So, we have discussed in the module 7 regarding process intensification by monolith reactor, and in this lecture of this module we will discuss something about preparation of monolithic catalyst, how to prepare that monolithic catalyst, and later on in the next lecture we will discuss about the application of monolithic catalyst in chemical engineering process. So, before going to the application, we will try to learn something about how to prepare the monolithic catalyst in this lecture. So, as a recap, we can recall that previous lecture about that monolithic structure, and then how monolithic structure is actually being applied for the chemical engineering process intensification. And in ancient that architectural structure, that actually the different shape of that they are house, buildings they have developed, and this is one type of, it is called monolithic structure. And here in the slides it is shown that there are different monolithic structures. So, from this structure concept, how this structure can be actually utilized to actually develop a reactor for the chemical engineering processes. So, that concept is give you the the intensification of the process in chemical engineering different processes. Now, for that, whenever you are going to develop any chemical engineering reactor based on this monolithic structure, that is structure based reactor. So, in that case, this structure actually made in this particular fashion, where the catalyst is to be actually embedded here in the structure, so that through the catalyst bed on this particular structure will help for the reaction in the chemical engineering processes. So, that is why the monolithic structure support that reactor, even that catalyst support of this type of structure is being nowadays actually very important for the chemical engineering processes. Now, there are different structure that we have discussed in the previous lecture, like that honeycomb structure, channel based catalytic, different shape of the channel will be there. Based on that, the reactors of this particular structure is being developed for the process. So, here in this slides we have shown that different shape structure of the catalytic monolithic structure reactor based on the concept of that ancient architectural structure. And after that, whenever reactor is being developed or is developed, and how this chemical engineering process can be applied here, it is shown in these slides there. Now, generally here typical example like biodiesel production, and where transesterification reaction is being done on this monolithic catalytic reactor. And in that case, the catalysts are the key for sustainable development in the chemical process industry. We have already told that the around 80% of the chemical products in the world market are manufactured via heterogeneous catalytic processes. In that case, vast majority of such reactors used in the gas liquid process, which contain catalysts in the form of either stationary or moving particles of various shapes and sizes. Now, this catalyst will help the synthesis of the product in a resource protective way with less consumption of energy, and in some cases without any formation of byproducts and also waste. The catalyst, especially if they are applied in a structured way, it will play an important role in integrated that approach to environmental protection in a particular that way, where the intensification of the process is actually being carried out based on this catalyst structure. They include the integration of various operations such as chemical reaction, separation and heat exchange, and also there may be that momentum transfer, that is several hydrodynamic aspects are also working on this particular reactor, based on which the performance of the reactors will be actually that assessed. And of course, before going to that discussion of the catalyst structured bed different monolithic reactor, in that case what are the different shapes of the industrial catalyst are actually being developed, that to be actually noted down, like here different structure of the catalyst, here irregular, granular, earlier it is as a the dispersed phase of catalyst is being used in slurry reactor. Here spherical particles which are being used in the slurry system, where the gas, liquid, solid reactions are being carried out. And also ring type, where packed bed are actually used for the chemical reactions in a packed bed condition with this ring type catalyst. And then pellets types and other that cylindrical shape, tri-lobe shape, even meaningless cross ring shape, even wagon wheel shape catalyst particles, even monolith catalyst particles are shown in the slides here. And after that that assessing of chemical process based on this catalyst bed, it is seen that there will be a certain that shortcomings of that reactor of packed bed, that slurry reactor, even other different packed conditions, and where the reactor are being actually is acting as a that chemical engineering process equipment there. So, based on that catalyst bed reactor, it is seen that performance of the reactions are not up to the mark, that is that 100% conversion, or there will be some other shortcomings there, even maybe some hydrodynamic aspects, somewhere it is seen that the pressure drop will be very high, sometimes pressure drop is less also, in that where it is not also suitable for particular reactions. And also some other chemical engineering processes, where that that mixing of the phases and also the catalyst particles should be uniform to get the utilization of the whole surface of that catalyst bed. So, in that case that sometimes that development of the slurry reactor, where that fluidization reactor, where that that mixing, well mix of that catalyst particles with the phase mixing with the phase, so that that reaction should be more higher. Still there is some other that shortcomings of those reactors in packed bed slurry reactors. So, later on to get the more intensification of that reaction process, actually this monolithic type of reactors are being developed, and also it is being now in the commercial stage almost there. And there are several other even research and development is going on this monolithic structure reactor, where you can that intensify the process efficiency based on this monolithic structure. So, that is why the catalysts are being that synthesized, after that it it is given a shape of like this monolithic structure. And so, that is why the different shape of the industrial catalyst, like monolithic metal catalyst is one of the shape. And also monolithic foam is also another type of that shape of that catalyst shape. And monolithic ceramic structure also is there. So, there are three types here that monolithic metal, monolithic foam and monolithic ceramic. This type of structure is now being actually procured based on that that catalyst particles, catalyst metal, catalyst that suitable catalyst substances or solvent also sometimes is being used, so that you can get it as a foam type monolithic structure there. So, that is why we can see that there are several different types of that industrial catalysts are being here used from the beginning, that is from that in 1977 onward it is actually being developed in different shape of the catalyst. In this case, in present day that monolithic structure is one of the important shape of that that catalyst where based on that catalytic operation, catalyst aided any reaction in which that reaction is being carried out, it is called that monolithic reactor. Now, as per basic construction material, there are mostly two types of material based monoliths. There it is actually being procured. There are ceramic and metallic type. So, ceramic mainly cordierite, it is a silicate mineral that is found in metaformic and igneous rocks, and these ceramics may be that sometimes the that foam type ceramic also is being there. And also metallic, mainly stainless steel, metal alloys, etc. metals are being used for this procurement of this type of metallic monolithic structure. And ceramic monoliths are usually distinguished by two types, namely cordierite, it is called sometimes honeycomb that ceramic monolithic structure, and ceramic foam is another. Here in this slides, the shape of that cordierite or honeycomb type structure is shown here in this case, and also this is called that foam type ceramic structure there. And now question is that how to prepare this type of ceramic monolithic catalyst surface. In this case, this ceramic monolith structure has many straight and usually parallel channels, that channels type monolithic structure are being developed, so that you can expect that there will be uniform flow through the channel, also that slag flow type, or you can say plug flow type flow there, so that you can get that uniform mixing over the solid particles, so that you can get that more efficiency of the reactions. So, such structure are obtained by the extrusion method, Sol-Gel method and corrugation method. And extrusion method mostly actually used for procurement of making of that structure of this monolithic ceramic catalyst. And in this case mainly different types of metals or materials, oxide materials are being used in this extrusion procedure. I will show in the next slides how to actually prepare this that monolithic catalyst structure by this extrusion. And then Sol-Gel method is generally used for that giving the active support material procurement for this catalyst surface, and corrugation method is used for procurement of the metallic monolithic catalyst there. And also in this case, if we discuss about that preparation paths for the extruded monolithic catalyst, we are having this this structure. It is given by Avila in 2005 in their publication Chemical Engineering Journal. So, if you go through that paper, you will get the more illustrative discussion of this preparation paths for extruded monolithic catalyst. Here it is that given that for the manufacture of ceramic monoliths by extrusion, you get this low surface area monolith and high surface area monolith, as well as some integral monolith structure based on this extrusion method. And after that that you have to do this extruded materials of this low surface or high surface area monolith, even in integral monolith, you have to coat it by certain catalyst surface by suitable catalyst material. So, this is called incorporation of the support. So, you have to that make the support to this that suitable catalyst. That support may be that renovate catalyst based support, even high surface support also can be made based on the coated catalyst particles there. So, incorporation of that active phase by this that coated catalyst surface on this catalyst particles on this support material of this monolithic structure, there it should be that the integration method, And now, based on this impregnation, you can use that coated catalyst, suitable coated catalyst, and also different types of impregnated catalyst and also extruded catalyst should be used. And this impregnated catalyst and extruded catalyst should be referred to as incorporated catalyst there. So, there are 3 different types of catalyst can be used for the impregnation for the active surface of this catalyst on the support material. So, that is why the support material should be coated by these different types of catalyst particles. So, then you can get that that particular structure on which that catalyst layer will be there and through which that flow will be there will be the reaction will be there for that particular chemical engineering process. Now, in this case the selection of one preparation route or that another, that depends on the type of catalyst that should be desired for that particular processes or particular reaction. Now, the type of ceramic monolithic catalyst after extrusion, you will see that there are 3 types of ceramic monoliths are there: low surface area monolith, carrier based catalyst, and high surface area monolithic support based catalyst, and integral monolithic catalysts are there. And then materials for the extrusion of course should be selective, and to make that ceramic monolith by that extrusion process for the particular shape of like cordierite or honeycomb structure, in that case you have to use some material for that monolithic extrusion. And most common material for the monolith extrusion is the mixture of cordierite. It is actually the ore of magnesium oxide, aluminum oxide and silicon dioxide mixture. So, and then you have to add with that cordierite with alumina, which is basically obtained from that ore of kaolinite, that is aluminum oxide and silica crystals there. So, in that case this main materials which is actually being used initially for that extrusion process for the preparation of ceramic monolith is called the cordierite material. Other materials also you can use, such as the silicon carbide, bismuth carbide, even some other materials here, even boron nitrate, or even that aluminum nitride, silicon dioxide, zirconium oxide, other oxide also you can use, and also mullite also, aluminum titanate, lithium aluminate, silicate, this type of that materials also can be used for the extrusion of materials to make that ceramic monolithic structure. Now, more than 90% of all monolith catalyst that is being used for the clean up of exhaust gases from the cars are of this cordierite ceramic monolithic structure monolith there. So, this type of material is being used generally for this extrusion for the that preparation of ceramic monolith. Now, what are the steps of that extrusion? One by one procedure will be there. In that case, the extrusion of process is conducted with the specially it is that designed that extruders and generally involves that 5 steps. The steps are like this, that preparation of the starting mixture of materials that contains aluminum and silica and other suitable materials, and it is then drying. After that, what you have to do, you have to mix that that materials well and bring it to the mix, bringing of this mixture into the state where suitable for shaping by adding the required some additives, it is called plasticizers or other organic or inorganic additives. And after that, using this appropriate die shapes, that you have to design that structure of this monolithic in a particular shape. After that, you have to dry to obtain a uniform structure without cracking. In this case, for this that getting this uniform structure of this monolithic structure. So, you have to dry. Now, that drying should be a particular temperature, that should be that thermally stable, and in that case you have to careful that whether it is being cracked or not. Then you have to change the material in suitable material where that you are not getting any cracking after drying. Generally for this cordierite materials, it is not being actually cracked at 1473 to 1773 Kelvin. So, finally, this thermal treatment, that is drying, calcination and sintering should be done at 1473 to 1773 Kelvin there. So, these are the different steps. These 5 steps are actually being followed for this extrusion process. Now, what are the different effect that on the properties of that extruded ceramic monolithic catalyst are being by that extrusion process? It generally depends on the type and properties of the starting materials, what type of materials you are initially using for that extrusion process, and also what type of additives you are using, what are the that medium condition, like whether it is acidic or alkaline, that you have to know. That is why you have to maintain certain pH of that particular medium to make that shape in that extrusion process. And also you have to wisely use the water content, that is also very important. To get that that mechanical strength, there should not be that enough water content in that structure. And also pressure, that is also another important factor which may that effect on the properties, that is called mechanical properties of the extruded ceramic monolithic catalyst. So, the additives are generally being used as celluloses, calcium chloride, ethylene glycols, diethylene glycols, even that alcohols, paraffins, heat resistance, some inorganic fibers, etc. So, these are the additives generally being used for the that extrusion process to make the ceramic monolithic catalyst. And the additives are used to enhance that resistance to temperature shocks, better porosity and this adsorbability, and to improve the mechanical properties. So, you have to remember that you have to use some suitable additives where you can enhance the resistance to temperature shocks, better porosity and also adsorbability. And also I told that an addition to the water, that is that other solvents can be used as well, so that you can get that more stable structure of that monolithic catalyst. In that case, ketones, alcohols and ethers can be used along with this water. Another important method is called Sol-Gel method. It is generally a calcination of the mixture of clay, talc and other components with aluminum and silica, and its advantages are resulting like high purity cordierite ceramic, that is attributed to higher purity of the starting materials. And also in this case you have to use that certain proportion of that clay or talc or other components material with that aluminum and silica, because that to get that microstructure should be well thermally stable. So, that is why cordierite ceramic material that should be that high purity and with a certain proportions also. And adjustable homogeneity on the atomic level also, it should be considered there. So, it is there in the Sol-Gel method. So, in this method it can be easily adjust that homogeneity on the atomic level. And also in this method it is possible to carry out the process at that lower temperatures at 1273 Kelvin also. And in this case addition of various components at one step is actually feasible. That is why this method is very advantageous compared to the other method. Whereas in case of corrugation method, for the preparation of ceramic monoliths, it involves the addition of inorganic oxides or salts to a mixture of that starting materials. And in this case addition of the additives like different materials that earlier we have discussed, that this type of materials for the additives like cellulose, calcium chloride, ethylene glycols, diethylene and glycols, alcohols, paraffins, etc., are actually that to be used, and also binders and plasticizers, fibers for reinforcement of the monolithic structures. And also after that, in this process that you have to roll it down, and then stacking should be done. Finally, the calcination should be done at a particular temperature, which should be that selected in such a way that it should not be, the material should not be cracked at that particular higher temperature. Now, let us have some that leading manufacturer of this ceramic type of monolith like Corning Company. Here these websites are given, Cormetech, NGK, that Engelhard also very important in this respect. They are also producing different types of ceramic monoliths, even Steeler, GmbH and also KWS. These are the companies, actual potential companies, they can supply this type of ceramic monoliths, and they are also manufacturing this type of ceramic monolithic structure. Now, how to actually prepare the ceramic monoliths with porous walls? In this case, the addition of appropriate polymers like polyurethane, naphthionase, perfluorosulfonic acid, and also that PTFE, that is polytetra fluoroethylene copolymer in that hydrogen ion form, etc., to the starting mixture for ceramic preparation. In later stages, what you have to do, that you have to do drying and oxidation, and then you have to perform this drying and oxidation at high temperatures. In this case, the polymer will be removed at that high temperature, and thus giving the required that macro structure or macroporous structure, that ceramic monoliths. And in this case, this ceramic foams monolith catalyst, also another type of monolithic catalyst. In that case, how to prepare? In that case, that it is generally being used to filter molten metals and hot gases, and they are preferred for the reactions where a low pressure drop is required, and in this case the porosity of the structure that favors turbulent flow, which enhances mass transfer with compared to cordierite structures. And conventional heat through the pores, that results in good radial mixing and hence improved that heat transfer. That is why this ceramic foams is also procured as an alternative of that ceramic monolithic catalyst, and because it has some advantage of that low pressure drop in the particular preferred reactions where the pressure drop will be low, and also the porosity of the structure that may sometimes that favor that turbulent flow for the enhancing that mass transfer, and in this case it will be advantages over the that cordierite structure. And in this case, one of the important aspects that you have to remember, that here you will see that convection of the heat through the porous materials will be resulted, and it may give the good radial mixing and hence improve the heat transfer, and it is very important for that particular reaction where that it is generally being in endothermic or exothermic reactions there, how heat will be distributed over there. And also you will see that in this case you can use that some that molten metals and hot gases for the particular specific chemical engineering process for reaction purpose. And ceramic foam, sometimes referred to as reticulated ceramics, which are three dimensional cellular structure in which the cells are connected by open windows that may give the high porosity of the order of 80 to 90% void fractions there. And how to then prepare of this type of foam monolithic catalyst there. There are several steps are there. Here in this case, like you have to first make a mixture of ceramic powder with water, that is slurry system you have to make with organic monomer, even dispersion some plus catalyst particles. After that you have to mix it well, and then you have to add some foaming agent. After that you will see at a certain temperature this foaming will be formed, and then you have to make it that in the form of gelation, and then after gelation you have to dry it, and then finally you have to sinter it to get that foam type monolithic structure. So, in this case various shapes can be prepared due to the relatively easy preparation method by this procedure. So, in this case you can get the composite material of the cellular foam, that is heat treated to remove that undesired constituents like polymeric substrate and sinter the inorganic particles together. Now, in this case this type of material can be prepared by immersing open cell organic foams made of typically polyurethane in a slurry of inorganic particles like alumina, silica, etc. To improve the mechanical strength of these ceramic foams, that what you have to do, a fused crystallized glass coating can be used, or the viscosity of the slurry can be adjusted. So, that is very important. You have to remember that you have to adjust the viscosity of the slurry. Initially you are actually making the mixture of ceramic powder with water to make the slurry, along with that organic monomer and dispersant, and also catalyst. In that case you will see that there will be a slurry system, that viscosity of that slurry should be adjusted by that giving the proportionate of that ceramic powder, because if you add more ceramic powder there may be viscosity will be higher. So, effective viscosity will be changing, because the slurry system has that apparent viscosity change with respect to time also. So, that is sometimes it is referred as the pseudoplastic fluid. So, that is why to get that higher strength of the ceramic foams you have to use some a fused crystalline glass coating, and in that case otherwise you can use that appropriate that maintenance of that viscosity of the slurry. Now, monoliths as catalytic carriers, that is low surface area monoliths, how to actually that used, that is to be used as carriers, your monoliths should have the following characteristics. In that case you have to remember, like as per Avila et al, they pointed out some that characteristics of that monoliths catalyst which is to be carried out as a carrier, which is to be actually used as a carrier. So, in that case very low thermal expansion coefficient should be there. It should be less than equals to 5 into 10 to the power minus 6 Kelvin inverse, and which may lead to a higher thermal shock resistance and maintains the stable wash coat there. High melting point and thermal stability and adequate mechanical properties to support the operating conditions to which they will be submitted, and also an adequate plasticity to permit their extrusion and immediate conformation into rigid structure with monolithic shape. In that case a certain roughness of the porosity that should be suitable for an effective wash coat application there. So, these are the different characteristics of monoliths which can be used as a carriers there. And also you will see that for high surface area you will get also some other characteristics. In that case thermal stability should be less, and in that case this thermal stability is less important, but high surface area and high amounts of support material per unit volume and monoliths are, in that case it will be necessary. These monolithic catalysts are manufactured following the same steps that is outlined in case of that extrusion of cordierite materials, but in this case using the corresponding raw materials, the basic steps should be followed, like here dry mixing of the solid raw materials, and like here solid materials, it should be oxides or salts and binders. And then what you have to do that you have to do it wet mixing and kneading, where water and additives like organic and inorganic substances to be that used, and then extrusion of the paste through special dies to form the monolithic honeycomb step, and then drying uniformly at 30 to 100 degree centigrade, and then you have to sinter it or fire it, and then that removal of that temporary binders at 400 to 800 degrees centigrade. So, these are the steps that you have to follow to get this high surface area monoliths. And in case of integral monoliths, in this case some necessary control of the thermal treatments should be done as well as drying and firing. And during these steps, the following process must be carried out, like that elimination of the solvent, generally water should be done, decomposition of the inorganic additives that may be included as plastifiers, which may cause the local temperature rises and also significant transformations in the porous structure of the solid. And these possible transformations in the material that is used as a support, especially related to changes in the crystalline phases and also porous structure. Now, finally, what you have to do that you have to transform of this precursor into the catalytic active phases, and the transformation that may involves the decomposition of their salts with the subsequent formation of gases like NOx, SOx, even COX also. And this can be carried out over an established support, as in the case for the impregnated catalyst, or you can do it while the support is forming its structure. After that, you have to see up to this we got that different procedure of preparing that monolithic structure, whether it is that ceramic foaming high surface or low surface area based monolith structure. After that, you have to incorporate of the active phases into the monoliths. So, in this case extruded catalyst, the incorporation of the active phases in a monolithic support for the high surface area and low surface area that should be coated with the support should be carried out in that case. So, incorporation is very important for this activating the surface of the monolith surface. Now, active phase incorporation procedures are there are several other that procedures to incorporate these active phases, like impregnation is one method that we have discussed. Except this impregnation, we can get adsorption and ion exchange method, precipitation or co-precipitation method, deposition or precipitation method, sol gel method, slurry deep coating method, in situ crystallization method, addition of catalytic species to the mixture of extrusion, chemical vapor deposition, even you can say that spray coating is also another important method to incorporate these active phases over the monolithic structure. Now, how to select those that active phases material there. So, both the nature and concentration of the active phase that is to be incorporated, and the type of active phase precursor to be used, and also the process in which it is to be used, namely the operating conditions to which the catalyst will be submitted, and also the possibilities of the deactivation by chemical or physical agents to which it will be exposed. So, these are the several factors actually which may give you the direction for the selection of a method for this that incorporation of the active phases on the monolith surface. And the conditions that actually affect on that incorporation method, generally time, temperature, pH and concentration of the reactive etc. Now, active phase distribution models are there to analyze that exposing of the active phase on the monolithic surface. Now, as per Lee and Aris, they have described actually a certain that models according to their experimental observation, and also that their procurement of that solid materials, that is monolithic structure materials, and they have suggested that on particular models of the distribution for that active phases. In this case, they have actually stated that the active phase incorporation can be directed towards more exposed zones or more protected within the wall, that may lead to the 4 active phase distribution models within the monolithic wall. So, as per this structure given in this slides, they are active phase distribution on the monolith wall. They are here this figure, you will see that how this active phase distribution can be done in the monolith wall. There are 4 types of that the exposing or activating the phase distribution there, like type 1, type 2, type 3 and type 4. Type 1 is uniform distribution models, and type 2 is this egg shell distribution model, type 3 is egg white distribution model, and type 4 is egg yolk distribution model. And based on this model, they have assessed that how that we can actually activate that surface of the monolithic surface. Now, after that we are just considering that metallic monoliths, how to prepare, because we have discussed here how to prepare that monolithic ceramic structure, and also low surface area, high surface area, different structure by different methods. Now, how to prepare that metallic monoliths, this is also one important type of that monolithic catalytic structure. So, in this case, development of this metallic monoliths actually started in 1960s, mostly for the needs of chemical industry, and these type of monoliths are almost exclusively obtained by corrugation, that means flexing of flat and corrugated metal plates and also or bends. The corrugated sheets can be prepared in several ways and are then cut to obtain the required shapes. For example, if you are actually preparing parallel or spiral types of structure, then you have to use this corrugated sheets, and which can be prepared in this particular shapes by a particular process there by corrugation method. And in this case, what are the metals actually to be used to prepare that metallic monoliths? The thin metal plates or bends, whatever shapes you are going to make, usually it should be iron, chromium, aluminum and rare metals. Some of the material that is used to prepare metallic structures include nickel, iron or chromium alloy that may contain aluminum, even some other materials like iron and steel composite material, that is called AISI, that is American Iron and Steel Institute, that is marked at AISI 304, and also aluminum foams can also be used to make these metallic monoliths. Now, in this case, oxidation of the aluminum produces a layer of aluminum oxide, which is important for good adhesion of the second oxide layer for support to a catalytically active component. And metallic monoliths can also be that made of stainless steel, and the material under the that trademark of ferrochromium alloy. In that case around 73% that iron and 15 to 20% chromium, and also that 5% aluminum should be used, and other some trace elements like rare metals to be used there. So, for this metallic monoliths can also be made with this this composite material of this iron, chromium and aluminum with small amount of rare metals. Now, how to source this metallic substrates to prepare that monolithic metallic that structure or catalyst. So, in this case the choice of a metal alloy to be used as catalytic substrate, that depends on three main groups of characteristics as per Avila et al. 2005. Now, in this case the properties related to the use of catalyst like mechanical properties, thermal properties, chemical resistance under operational conditions, and another important that characteristics that is very important to be considered for the choice of metal alloy. In this case the properties related to the catalytic coating adhesion, and also the properties related to the fabrication process, whether it should be capable of rolling to thin foils, or whether it should be weldable or not. So, that should be also keep in mind whenever you are going to choose the metallic substrates for the procurement of metallic monolithic structure. Most important point here the properties that is related to the use of catalyst, because in this case for automotive use that presents the most stringent conditions of this which is where properties related to the use of catalyst, that is whether it is mechanical, thermal or chemical resistance or not. So, this point actually being keep in mind for the procurement of that metallic monolithic structure. In this case that is why it is very important for the automotive uses, where this stringent conditions of the temperature, atmosphere, durability and mechanical stresses are to be considered. Therefore, steel and other iron alloys are the ones that is most frequently used for the preparation of this metallic monolithic structure. This is generally for catalytic converter in automotive vehicles. And metal catalyst substrates offer a variety of solutions for all combustion engine applications. In this case you will see that significant reductions of the emissions like hydrocarbon, carbon monoxide, NOx and even particulate materials there, and in this case that reductions of those materials can be achieved for both spark ignition and diesel engines. And also based on these metal catalyst substrates you can develop like cone shaped catalyst and open particulate traps that may help to meet the future emission legislation. And also based on these metal catalyst substrates, new high cell density ultra thin foil substrates that further increase catalyst efficiency, they are for the particular application that you can consider. So, these are the that variety of solutions for all that combustion engine applications based on that metal catalyst substrate. And in this case this metallic monolithic structures are manufactured by leading manufacturer of like that some companies are given here with websites here in the slides, Johnson, Matthey, Amitech, Grace, those are leading companies, even potential companies, they are that in huge amount of this type of metallic monolithic structure they are procuring and commercialized in the market, they are actually selling in market. Application of secondary support to the monolith structure, in that case the specific surface of the ceramic and metallic monolith support is very small for the cordierite ceramic monolith. It is approximately 2 meter square per gram, and therefore, primary support the monolith has to be coated with the secondary support, usually a layer of the porous metallic oxides such as aluminum oxide, silicon dioxide, mixture of the oxides, etc. Now, wash coating is very important. In that case, it is generally used to do primary support, and coating of that monolith surface of the oxides requires the solution or colloid suspension with precursors of one or more oxides. Precursor is in the form of suspended particles there. And another important point that should be remembered, that for the that secondary support also you have to make for getting that stable condition of that monolithic structure. In that case, hydraulic and non-hydraulic salt gel methods are important. So, in some instances the salt gel method is applied where the liquid phase contains secondary support precursors. Hydraulic procedures based on hydrolysis of the appropriate alkoxides in the presence of either acid or base that can be applied to do this, that may be followed by polycondensation. So, here in this slides this polycondensation process is given and the reaction is given here. You can do either this method, or you can do it by non-hydrolytic salt gel procedure also. That for non-hydrolytic salt gel procedure is given here. In this case, the prepared salt is applied by dipping technique, and after a predefined time excess salt is removed from the monolith, which is then dried and calcinated to get this secondary support. As an example, aluminum salt can be prepared with various aluminum precursors like pseudo boehmite crystal and also aluminum alkoxide, etc. Additives such as urea or organic amines like hexamethyl tetraamine and also other materials also you can use as for improve the quality, and in that case quality improvers of aluminum oxide layer should be used there. This type of additives that you have to use for this making of this secondary support. After that, decomposition of additives at high temperatures, that is calcination, as per following equations, that is gives this layer the required porosity as per Zhu and Moulisin in 1998 they have given this that reaction procedure to decompose the additives at high temperatures. Now, additives have the influence on the stability of the salts. So, in this case remember that metals unlike ceramics have significantly higher thermal expansion coefficient. Therefore, during the application of an appropriate support of a catalytically active component to the metallic monolith base, the adhesion of such a layer that may requires particular attention. Now, then how to design and manufacture of that monolith there. So, some aspects are given here. The most frequent design in metallic monoliths is based on the rolling or peeling up. In this case, see the figure, alternate corrugated and flat strips are there, and also multiple parallel channels are generated in between the corrugated strip. Crimping a metal foil on a pair of rollers that have sinusoidal or triangular teeth that produces that corrugation, and variation in the number of cells per unit area is achieved by varying the piece and width of the profile on the crimping rolls. And then pulsate flow and vibrations produce the deformation of the center of the cylindrical rolled monoliths that are pushed out during use. They are like telescoping application. This phenomenon can be prevented by forcing pins through the layers that may be perpendicular to the channels, or using various forms of welding and brazing between layers or across one or both end faces of this structure. Now, here some historical that aspects of that structure of this monolith are given here from the beginning of 1960 spiral type, that even 1968 and in spiral, and then there will be cross connection, and then 1978 the spiral again, and then braced connections, and then that what is that S type in 1986 they have, even SM type 1991. So, this type of that several structures are manufactured by metallic substrates for this monolithic catalytic structure. And other like the structured maybe microstructure, micron in size, like that channel based, that may be micro channel based that monolithic structures also there, that is a microstructured monolith is actually prepared to increase the turbulence inside the channels there. So, to increase that turbulence you have to make this microstructure in channel based. The microstructure is to that produce both in the flat as well as that crimped foil that may be perpendicular to the microstructure forming the channels there, as per figure as shown in here, as per reported by Avila in 2005. Now, these both the microstructure and channel interconnections though increase the pressure drop, but it may increase the monolith efficiency, and this efficiency allows the length reduction that may compensate the increased pressure per unit length. So, we have discussed that several aspects of that preparation methodology of different types of monolithic structure, that is by extrusion, by sol gel method, by that other methods also, even for low surface how to produce that, and also for high surface area how to make that macro porous structures, how to make the foam structures also, and also what are the different that conditions for making that different type of monolithic structures that we have discussed in this lecture. I think you got some information about the preparation method. For getting more information of this preparation method, you can go through these references and for further reading. So, I think it will be helpful for you. So, thank you for this lecture.